Hi friends, welcome to Code World YouTube channel. My name is Basha. In the previous video, we had discussed about assignment operators, arithmetic operators, INT operators, and membership operators, right? In this video, we are going to discuss about logical operators, comparison operators, and bitwise operators. Okay. First, I'm going to discuss about comparison operators. Comparison operators are used to compare two variables or two values. Comparison operators are is equal to, are not equal to, greater than, less than, greater than or equal to, less than or equal to. If you remember, we already discussed about this in previous video, conditions and if else. I'm not going to explain here. The link of that is in description, so please check it out. I'm gonna show you a program here. Okay, let me open my text editor. Okay, see, print 3 greater than 5. Okay, 3 greater than 5. If you run this, it is false. 3 is not greater than 5, right? That way it's false. This comparison operator gives either false or true. If the condition is true, then it will give true. If it is false, it will give false. That's why 3 is not greater than 5, right? That way it will give false. Okay, let's try another one. 10 is equal to 10. Okay, so it is 2. 10 is equal to 10, right? That's why it is 2. If we place not equal to here, then it will be false. Okay, like this. If we print greater than or equal to, okay, it is false. If we place less than or equal to, it is 2. Like this, we use these comparison operators. Okay, I think you understood. Next, logical operators. The logical operators are logical and, logical or logical not. First, I will discuss logical and. The logical and return true if the both operands are true. In any other cases, it will give false. Let me explain with the example. Okay, clear this. I'm going to take a variable a that is equal to 2. Okay, next I'll take a value b that is equal to false, and the variable c that is equal to 2. I take 3 variables a, b, c. A is 2, b is false, c is 2. Okay, I'm going to perform the logical operations on these variables. Okay, print a and b. Okay, see what happened. And run this. See, it is false because if the both operands are 2, then this logical and return 2. Else it is false, right? That's why a is 2, b is false. So one of the operand become false. That's why it is false. If both operands are 2, then only it is 2. If we replace b with c, then a is 2 and b c also 2. That's why it return and this 2. Okay. Let's try another also. Okay. C and b. Okay. This is false, right? C is 2 and B is false. That way it becomes false. Okay. Next, logical OR. Logical is quite opposite. Logical OR return false. Both operands are false. Logical AND return true if both are true. Logical OR return false if both are false. In any other cases, it will return true. Okay. Let me explain with example. For within same example, I replace all with AND with OR. OR. Okay. Here also I replace AND with OR. See what happened. 2 and 2 because a is 2 and c is 2, both are 2. That's why 2. And here c is 2 and b is false, both are, one is 2, one is false. That will return 2. In logical, both are false, then return false. Let's take another variable to show that. But I'm taking b is equal to false, then show here. Let's show here. D or B. Okay, here both are false. D is false and B is false. That will return false. Okay, I think you get my point. Finally, not logical not. It is simple. Return 2 if the operand is false. Return false if the operand is 2. Okay, Let me show you the example also. We'll take a variable a is equal to 2. Print not a. A is 2, right? That way return false. Let me execute this. False. If I take b as false, not b. B is false. If I make not, return 2. Okay. Next, bitwise operators. In Python, bitwise operators are used to perform bitwise calculations on integers. The integers are first converted to binary numbers and then operations are performed on bit by bit. The result is returned into decimal format again. Okay. The bitwise operators are bitwise AND, bitwise OR, bitwise XOR, and left shift or right shift operations. And all operations are same as logical operations, but the operations are performed on bits and numbers. Okay. XOR, if the both operators are same, then it is false, else it is true. That is, both operators are different, then it is true. See the truth table. Here input and output values are zeros and ones. 0 means false, and 1 is true. Okay. Bitwise and return 1 if the both operators are 1, else return 0. Let me explain this with example. Okay. Let me take a variable a is equal to 2 and b is equal to 3. Okay. Now print a for, and we use applets in symbol here, and b. Okay, we run this. See, two values appeared. How it is? Let me explain here. I will explain here with this. Okay, 2. The value 2 in binary format is 0 0 1 0, right? This is equal to 2. Okay. Next, the b value is 3. 3 is equal to 0 0 1 1. Okay, this is 3, right? We perform AND operation on this. What will appear? If you remember, AND, if both operands are 1, then it is 1, else it is 0, right? Okay, then 0 0 0 0 0 0 and 1 1 become 1 and 0 1 become 0, which is equal to 2, right? Then okay, that's why it is 2. Okay. Next, bitwise OR. Return 0 if both operands are 0, else it return 1. Let me take example to explain this. Same example. I will replace this AND symbol with OR symbol. The OR symbol is pipe here. Okay. We run this. 3. I will explain with this example to show you. Okay, now we will perform OR operation. The OR operation is, the both operands are zeros, then it is 0, else it is become 1, right? If both operands are 0, then it is 0. If anyone is 1, then it will become 1. Okay. Now in this is 0 0 0 0 0 0 1 1 become 1, 0 1 become 1, right? This is 3, right? 3. Okay, this is OR operation. Next, I will explain XOR. For XOR, we'll use this symbol. Okay, let me run this. See, 1 appeared. Why 1? I will explain now. XOR. Both operators are same, then XOR return 0. Else, if both operators are different, XOR return 1. So, see here, XOR operation for the same operands. The XOR operation. The 0 0 become 0. Next 0 0 become 0. And 1 become, both operands are same, right? That's why 0. Okay. 0 1. Both operands are different. That way it return 1, which is equal to 1, right? Okay. That's why it return output as 1. Okay. Next, shift operations. There are 2 shift operations, left shift and right shift. I will explain with examples, then it will become clear. Let me clear this. Okay, shift operation, first left shift A, the operand A, left shift 2 bits. Okay, let me run this, become 8. Why 8? I will explain now. Okay, let me clear this all. Perform on operand A, right? Okay, this is operand A value. A is 2. Okay, 0 0 1 0 2. The value 2 is equal to 2.000, right? Okay, perform. Okay, put how many zeros we want on after point, right? This is same as 2. So in bits also perform after point 000. Okay, left shift, that means we'll shift the bits to left side of this dot, this point. Okay, how many bits? 2 bits. Okay, 2 bits. What happened? 0 0 1 0. On shifting 2 bits, it became 0 0. We have taken 4 bits, right? That's why we ignore this 2 before, and after point ignore all of them. After point we'll ignore. It is equal to 8, right? That's why it's Q as 8. Now I will explain the right shift also. Point A, right shift 2. For left shift we use this symbol and this symbol, and for right shift we use this symbol. Okay, I will explain. I will run this. See, for right shift we give 0, y 0. Right shift, for the same variable right shift. See, in right shift we will shift the bits to right side of this dot. Okay, what happened? 0 0 0.10000. After point we will ignore all the bits, so I will delete them. See, 0 0, which is equal to 0, right? That's why it give our output as 0. Your assignment is try with different numbers and let me know in comment section. Okay friends, that's it for this video friends. See you in next video. If you like my video, please hit the like button. For more videos, please subscribe to my channel. Thank you for watching.